All right, back at it. Next video. Let's get it going. Okay, so let's just review some of these learning goals that I went over in that last video, which I know that one went a little long. Okay, so just take it in stride, right? Take it one concept at a time. Okay, but what I went over, okay, just to make sure we're all clear, what color do I have? Let's get a yellow. Okay, I think that's right. So, okay, understand the concept of the mole and how to interconvert masses, number of particles, atoms, etc., given a set of data. Okay, that was definitely covered over in that previous lecture. All right, in lecture number 7. Be able to calculate molar mass for a given chemical formula. Yep, we did that as well. Okay. Be able to balance chemical reactions. We definitely did that. And I understand, you're only seeing me do this thing like once or twice in the lecture, and I'm highlighting the learning goal, like, yep, we did it, move on. But remember, okay, you might be in this category. Well, I'm not ready for a test. Or maybe you're even in this category. I feel okay, but I need more practice, right? So remember, use this document as a means of guiding yourself through the material, okay? You can tell by now I go through things a little on the faster side because we do have a lot of content to go through, okay? So I might go through something really fast and then move past it. Make sure that you feel good about that before you move on, okay? And then I think the last thing we talked about, being able to come up with a balanced combustion reaction given any hydrocarbon. So I went through a couple examples, and I noticed, you notice I said CXHY, right? I gave you the example of methane, which is CH4. I gave you the example of propane, which was C3H8. I gave you the example of butane, which was C4H10. And we even did octane, but you didn't know I did octane. That one was C8H18, okay? And more on octane in this video, okay? And so it looks like after one video, I got through all, or half of these learning goals, okay? These other ones, I'm gonna go a little bit slower because there's gonna be a lot of example problems that I work through, okay? But first, I do want to spend just a brief moment talking about the carbon cycle, which you notice wasn't anywhere in the learning goals, right? So this is a little bit extra, but I think this is good stuff for you to know, okay? So, combustion of hydrocarbon, right? We noted that it's any hydrocarbon, CXHY, plus oxygen makes CO2 and water. I think I realized I also neglected to go through this in the last lecture, right? But I hope that this is obvious. G for gas, right? And in combustion, take note of that. These are all gases, okay? And for the combustion, it can be a gas or liquid, so liquid, L. Gases ignite more readily than liquids, and we can talk about why that is later, but certainly I just mostly want you to recognize these symbols. We're going to see them more and more and talk about them more and more as we go, okay? So for example, this AQ stands for aqueous, okay, which means it's dissolved in water. And again, more on that in the coming chapters, okay? So, but what I want you to focus on, what I want you to compare combustion of hydrocarbon, right? Like such as gasoline, okay? And I mentioned octane. Octane is C8H18. That's the principal component of gasoline, octane. Okay, that's what you put in your car to make it go. Okay. Look, respiration. Let's look at this reaction. Okay, C6H12O6. As it turns out, that's sugar. That's glucose. Okay. But look how similar that is. Plus oxygen makes carbon dioxide and water. That's very cool. So everyone breathe with me. And I want you to know that the carbon that you exhale comes from the carbon that you eat. Okay? The carbon that you're exhaling is coming from the carbon that you're eating. That's a very oversimplified version of that, and those of you that are biology majors will go on to learn probably far more than I know about respiration. But I think that's a pretty cool idea, right? That we consume fuel and we exhale the CO2 and the water. And of course, we exhale a little bit of O2 as well, right? But for this idea of respiration, particularly mammalian respiration, right? The carbon that we exhale is the carbon that we consume, okay? And then now let's compare that to photosynthesis. It's the reverse of respiration, okay? So what that means is combustion of hydrocarbon is a source of CO2, okay? Respiration is a source of CO2. So there's a lot of creatures out there in the world that are exhaling CO2, and that's a significant source of carbon dioxide in Earth's atmosphere. Photosynthesis is a sink of CO2. So while all of the mouth breathers like me are pushing out a bunch of CO2, the plants are taking it in and converting it into sugar and energy, all right? So this is kind of an oversimplified view of the carbon cycle. And those of you that go on to do, environmental science classes, you're going to learn a whole lot more about the carbon cycle. The main thing that I wanted to draw your attention to, when we think about all of this CO2 in the atmosphere, right? It's what we call a greenhouse gas, okay? And that CO2 traps heat in it, traps terrestrial radiation. So that's heat that's coming off the surface of the planet that would normally escape out into space, okay? But some of that is trapped. And it's okay that some of that is trapped. We're the Goldilocks planet. We want just a little bit of greenhouse effect is okay. That keeps us nice and toasty. However, with too much greenhouse effect or with too much CO2, that's a bad thing. And what I want you to take note of this, there are a lot of sources of CO2 in the atmosphere. There's a lot of things that produce CO2, like respiration. See, it's making CO2, more respiration. So that's respiration coming from, the animals in the ocean, or respiration coming from animals on the land, like me. You notice here, let's see, number 4 is, let's see here. Number 4 is CO2 that comes off of the land. So this is called detritus. I don't want to spend a lot of time talking about this, okay? What I mostly want to talk about is this, the combustion. And the source of CO2 from combustion is humongous. It's huge. And it's just getting bigger and bigger and bigger with the more human activity there is. And you notice the only thing that really takes CO2 out is photosynthesis. Photosynthesis through marine phytoplankton or just photosynthesis through terrestrial plants, okay? So right now, the sources of CO2 in the atmosphere, particularly from combustion, are far outweighing the sinks of CO2, okay? And even though these things, they might not seem like a lot to us when we talk about, the CO2 right now is about 400 parts per million. So that means for every 1 million molecules of air, only 400 of them are carbon dioxide. So it doesn't sound like a lot. However, the real important thing that's going on right now is because of this, there's imbalance in this carbon cycle. We're producing far more than what can be taken out. And particularly when we note that terrestrial plants are responsible for taking out carbon dioxide, but we're mowing them all down, right? We're cutting down the rainforests. That creates an even bigger issue. Okay, so that's all I'm really going to say about this, at least for now. And I certainly know I probably did not give this any justice at all, so I hope there's no environmental scientists out there like, wow, he just did a terrible job describing that. Again, I just wanted to give you a general overview. And those of you that get into this in your major, you're gonna explore this in a lot of detail. Okay. So let's keep going. Okay. And what we're gonna get into, and particularly, I'm gonna talk about these types of combustion reactions a lot with fossil fuels because I think it's important that we understand how we go from so many grams or milliliters or gallons of gasoline to translate that to how much CO2 is that going to put in the air. Okay.